Of course, there are a few other properties of the key light that we haven't touched yet. The color temperature and propagation, to name a few. The easiest way to control the color of the light source is obviously to use the RGB color picker. A cinematography analogy would be placing a gel over the light source to make it any color you want. Or let's say using an RGB LED panels. So that was color wheel, the first option that we have. Alternatively, if you are in the mood of dealing with the color temperature directly, you can click the Use Nodes button and then this dot near the color and choose Black Body. The Black Body node converts the temperature in kelvins to the RGB data. Basically, this slider controls a type of radiation or light color emitted by a black body or light source when it's heated to a certain temperature. These temperatures are measured in Kelvin. The hotter the temperature, the more blue the light appears. The temperature of 5200 makes it look like a daylight. 6500 is slightly cooler than that. It's like an overcast daylight. So yeah, basically the higher the temperature, the bluer the color. It is a standard way of dialing in the color of the light source, of balancing the light bulbs in cinema production, you name it. With that being said, to keep things simple, I will remove this node for the time being and rely on our good old color wheel instead. I will dial in the neutral white color with the saturation of 0, or using the RGB model, it should be 1 in both red, green and blue. Okay. The last slider that we haven't explored yet is the beam shape spread. As its name implies, it's a tool for shaping the directionality of light, and it can be imagined as focusing the beam, basically. From the default 180 degrees all the way to 1 degree, which makes it super focused. It is also important to note that it does correlate with the perceived softness of light. The smaller spread value does make the shadows harsher. I think we're good with the default spread value of 180, so I'm gonna control Z it all the way back. And let's imagine if we wanted to control the spread or propagation of the light beam, what else could we do? We could have used some kind of a blocker, just a regular plain object or a box. We could have simply blocked or cut the part of the light rays to better control the propagation. Actually, we will dive deeper into shaping the beam of light later on in the course, in the second chapter, where we will use different kind of blocking techniques, as well as light textures and dappled light techniques. That is a little teaser, so obviously stay tuned. Meanwhile, because we utilize a physically plausible path tracing render engine, such as cycles, we also automatically add some fill light in addition to our key light, just like it happens in a real-world production. So as we crank up the power of our directional light component, it also affects the power of the bounce. We can tell that the drop shadow part of the minerals isn't pitch black. It's because some part of the light rays got bounced or reflected by the environment. There are two types of bounces, diffuse and glossy, and if we dial in 0 in both, we will see what we would see in Eevee, let's say. We would see the pitch black shadow. And as soon as we bring back some of the light bounces and let cycles do its light transport work, the shadow will get filled in a little bit. And it totally depends on the power of the light source. It works in proportion to the power of the key. I suppose it should be super intuitive and feel like home if you worked with physical light sources in production. And again, with no light bounces, it will look just like Eevee. So let's switch over to Eevee for a second, just for fun. To make it look indistinguishable from cycles, the soft shadows in Eevee should be set to on, and then within the light settings tab, the contact shadows should be ticked. Otherwise, the shadows won't be precise enough. To double down on this, cycles with 0 light bounces looks very similar to Eevee, but once the global illumination kicks in, cycles path tracing gives us a nice fill in addition to the key light in the form of the indirect bounce. That being said, further down the line in the Monastery Dungeon chapter, to be exact, we'll discuss the global illumination methods for Eevee, namely its built-in irradiance map, as well as a real-time screen space global illumination, or SSGI. Consider this a quick teaser. Eevee is a great render engine after all, and it will get its time in the spotlight, no pun intended. Eevee is so cool, but still I'm gonna switch back to cycles in a moment. Personally, I love a physically realistic way the secondary light bounces are calculated in cycles. It's not that different from manipulating real light sources, and I think it just matches our learned expectation on realistic light transport, the secondary bounces specifically. It is a cool little effect that adds believability to everything, the photons bouncing around the scene and filling in the shadows. Well, not literally, but something like that. And the amount of the bounce light is again always in proportion to the amount of the directional light, and it makes the balancing of these two components really easy and intuitive. It's like a nice contrast ratio right out of the box. Okay, now I will dial back the power of our key lights to 3700 watts. Now everything about our main light feels right to me. We can start adding some detail, I think.